Welcome back. In this video, we can discuss about the next type of derived data type, that is about this union in C programming. So we have already discussed about this pointers, arrays and structures in our previous videos. Now we can go for this union. So a union is a user-defined data type similar to our structure in C programming. Okay, union and the structure, they have some similarities. Okay, a union is a special data type available in C that allows to store different data types in the same memory location. Okay, it allows to store different data types in the same memory location. This is one of the property of our union. It allows to store different data item in a same memory location. You can define a union with many members, but only one member can contain a value at any given time. This is the main difference of union with structure. Both union and structure can define with many members. In union, only one member can contain a value at any given time. Right? But in case of structure, any number of member can contain value at any given time. This is the difference of union with structure. Both contains or both represents different number of member variables, but in case of union, only one member can contain a value at a given time. Okay, but in case of structure, any number of structure members can contain value at any given time. This statement will become more clear in our coming examples. Okay, union provide an efficient way of using the same memory location for multiple purposes. So using this union, we can effectively utilize the allotted memory space in certain time, right? So consider the definition part of union. Just like our structure definition, here we can use the keyword union for defining this union. The syntax of defining union and structure both are almost the same. In structure definition, we use the keyword struct, but for the definition of union, we use the keyword union. Union space the name of union. Then inside we can indicate the number of members we want to represent using this union. Then end with a semicolon. This is actually the template of our union. Right? Consider one example. Union. The name is data. Inside this we have two members of this data type union. One is a character variable, another is a floating point type variable. Okay. Next is about creating union variables. The same syntax that we have used for creating structured variables. The same syntax we can follow here. Union name with variable names. If we need more than one variables, we can separate using single comma. Okay. In our structure, the syntax is like structure, struct space, structure name, then variables. Here use the keyword union instead. Union space, union name, then variables. Right? The another syntax is keyword union, then union name. Inside this braces specify the members present inside this union, then end with variable name. Okay, listed here the variable name and end with the semicolon. Both are valid syntax. This is the union declaration and variable declaration at the same step. Okay, we can follow this syntax or this syntax. Both are valid, right? So for consider this example, this is the case of structure declaration and this is the union, right? This str is the structure variable and uni is the union variable. Both have two different members. One is a character type variable, another is floating point type variable. Okay, while declaring this variable, what happened? This one is actually the syntax. From this, it is clear that the name of the structure is data here with one character type variable and one floating point type variable. Okay, while declaring this structure variable, what happened in our system memory? Here it allowed a single byte and is labeled using the name x. And also, suppose for storing a floating point type variable, here we require 4 consecutive bytes. Suppose float type variable require 4 consecutive bytes. So that in the same memory system, somewhere it allowed 4 consecutive bytes and labeled it as y here. This is the case of structure variable declaration. While declaring a structure variable like this, here it allowed 1 byte for indicating this character type variable, another separate 4 consecutive bytes are allotted for representing this floating point type variable. Now consider the situation of union declaration. This is the syntax of or template of our union. The name is data itself with a character variable x and a floating point type variable y. And while declaring this union type variable, what happened? While declaring this, move to the system memory and here it allowed 4 consecutive bytes. Okay, and that 4 consecutive bytes are shared by both this x and y. So this is the main difference of union from our structure declaration. Right here, while declaring a union variable, what happened? Consider this is a character, single character variable and this is a floating point type variable. And for storing a single character, suppose it require 1 byte. And for storing a floating point type variable, assume it require 4 consecutive bytes. Okay, from this example, it is clear that for storing this floating point type value, we need 4 consecutive bytes. And here it need only a single byte. Right, from this floating point number representation require more amount of memory space, so that it allowed that much amount of memory space in the system memory, right? So that particular memory is shared by both x and y. We want to initialize a character type value, then use the same space, and in from this space, from this consecutive 4 bytes, 1 byte is used for storing the value. Okay, and for storing the floating point value, use the same 4 consecutive bytes of space. We can store that floating point number value. From this, it is clear that in a union type data, we can represent or we can initialize only one of these two members. At a time, we can initialize only one among these two members because these two variables shared a common memory space, right? But here, this is not the case here. We can initialize both x and y at the same time because here we have separate memory allocation for x and y. Here we haven't any memory space sharing. Okay, so we can initialize both x and y at the same time, but this is not possible in case of union because both the variable shares the common memory space, and the memory space or the size of the memory allotted is always equal to the size of the largest memory requirement among these two structure member here. Here, this float type require 4 consecutive bytes and character type variable require 1 byte. Among these, this 4 consecutive byte is the largest requirement. So that it allowed that largest memory requirement here. And that memory space is shared by both x and y. Right? So this is the basic principle of this union type data. Now we can consider one program. Right, so here we have an employee of type union. Okay, inside we have an integer type variable for storing the id of the employee and a character type array. How many how many bytes are required for representing this character array? We need total 10 bytes. Right, so this name type character array is used for representing the name of our employee. Next, another integer variable age for representing the age of our employee, and the floating point type salary used for representing the salary of our employee. So all these are the members of this employee union. Okay, employee as a type union. Okay, so after that, inside this main, we can declare this employee type variable, that is capital E here. Using this variable, first we can read an ID of the employee from the keyboard, which is initialized here in this ID type variable. Scanf %d ampersand e dot id. This is the method of accessing members of union. Just like our structure member access, we need to use this dot operator for accessing the members of our union. Union variable name dot member name, right? So using this syntax, we can read one integer value from the keyboard, which is initialized here in this particular allotted memory space. So while declaring this, or while executing this union variable declaration, what happened in our memory, total 10 bytes are allotted. Total consecutive 10 bytes are allotted here. Why? Because among these 4 union members, here it requires suppose 2 consecutive bytes for storing an integer, and here it requires 10 consecutive bytes for representing character array name. Then 2 consecutive bytes for this age and 4 consecutive bytes for this salary. Among these 10 consecutive bytes are the largest memory space requirement. So that while declaring this union variable E, it allot this 10 consecutive bytes here in this system memory. Right? This space is shared by this ID, name, age and salary. Right? So while executing this particular statement, what happened? The entered ID value from the keyboard is loaded here in this space. Then we can display that value using this print statement. At a time, we can initialize only one member value because all these spaces are shared by these 4 member variables. Okay, for these union members share the common space. So first here read the ID of employee, which is stored here, then display that value. And then next time we can read the name from the keyboard, which is initialized or stored here. While storing the name, what happened? The previous ID value get replaced with new employee name. Okay, the same space is shared by all the members of union. So the previously entered ID now replaced with the newly entered name. Okay, so suppose the entered name is Nikki, which get dotted here in this space, so that the previous ID is replaced here. So while printing the name, what happened? It display the name value. Okay, so after that, while executing this statement, what happened? While executing this, it is going to enter the age of our employee. So the previous name Nikki get replaced with newly entered age value. Okay, so while printing this, the age is displayed. Right? So after that, while entering the salary value from the keyboard, this age get replaced. There we can store the salary, newly entered salary. And while printing, we can display the value, the salary value. So from this example, it is clear that the largest memory requirement is allotted here. That amount of memory is shared by all the members of our union. So that the main problem is at a time only one member can contain value. Only one of the union member can contain the value. Okay, so we can consider the program execution now. So this is the same program. Now we can execute this. The same program, employee with ID, name, age, salary, etc. as the members, and the same printf and scanf statement for reading and displaying ID, name, age and salary one after another. Okay, now we can execute. So first we can enter the ID and will display the ID value. Next we can enter the name that will displayed. After that we can enter the age, which will get replace the name that previously entered. Okay, now we can enter the salary value, which will replace the previously entered age value in memory. Okay, so this is the case of our union. Okay, okay, now we can compare the structure with union, right? Structure in case of structure declaration, keyword struct is used, and in case of union we use the keyword union. Okay, for the declaration and for the variable declaration, in structure it use the keyword struct, and in union it use the keyword union. Every member with structure is assigned a unique memory location. Okay, the main difference of structure with union is every member of the structure is assigned with separate memory allocation. But in union, memory location is shared by all the data members of union. Right? The total size of the structure is the sum of the size of every data member. Here all the members of the structure is allotted separate memory space. So the total size of the structure variable is the sum of the size of every data member. Right? But in case of union, the largest memory requirement is allotted and that space is shared by all the union members. So the total size of the union is size of the largest data member of union. Okay, it is mainly used for storing various data types. Okay, it is mainly used for storing one of the many data types that are available. Using the structured variables, we can store and retrieve many values at the same time. But here in case of union, it is used for storing one of the many data type that are available. We can store and retrieve at a time only one value among the different values, right? You can initialize and retrieve any number at a time in case of structure. Any member. Okay, you can initialize and retrieve many member at a time. Any member at a time because all have their own separate memory allocation. But here in case of union, all members are sharing a common allotted memory space. So you can initialize or access one member at a time in case of union. Okay, so these are the basic difference of derived data type structure with union. Okay, so basically this union can be used for effectively utilizing the memory space in certain cases. Okay, for in case of structure it require separate memories allocation for all the members, right? So while using this union we can reduce the usage or allocation of memory space because different members share a common memory allotted. Okay, so based on the requirement, if the memory usage is an important factor, then we can go for union instead of structure, right? So all these are about the structure and